Alright guys, today we're going to talk about solving an equation with a variable on each side. So on number 1, if you'll notice, we have an equation with an unknown b that they want us to solve for. The equation reads 5b minus 6 equals b plus 30. Now if you'll notice, we have a variable on each side of the equation. We have a variable on the left side and on the right. Now, all that we need to do to solve is get all of our variables onto one side of the equation and all of our constants onto the other. So if you'll notice, I have a 5b on the left side and a b on the right side. I want to get both of those variables onto the same side of the equal sign. Now it doesn't matter what side of the equal sign you want it to go to. You just have to ask yourself which one would be easier. Would it be easier to move the 5b over to the right side or the 1b over to the left side? For me, I feel like it would be easier to move the 1b over to the left side. So I'm going to subtract b from each side. Now when I do that, I'm going to have 5b minus b, which is 4b, and then I can bring down everything else. Minus 6, these cancel out, and that's going to equal 30. Now if you'll notice, this looks a lot like the equations we have been solving. It's much easier to solve this. Now we need to move the constants over to the other side, so we're going to add 6 to each side. And when I do that, the 6's will cancel out, and we'll be left with 4b equals 36. And then to get the b by itself, I want to divide each side by 4, and b equals 9. Now to check your solution on this one, we're still going to use our calculator like we have in the past, but it's going to be a little bit different because we want to make sure that both sides are equivalent. So if I substitute the 9 into the left side, I'm just going to write this out so you guys can see. You don't have to write this on your paper. I'll have 5 times 9 minus 6. And I want to know if that gives me the same number as if I were to substitute 9 in on the right side. So 9 plus 30. So I'm going to put that into my calculator and see what I get. If I take 5 times 9 minus 6, that gives me 39. So that means this side, when I substitute 9 in, I get 39. And on the right side, if I take 30 plus 9, I get 39. Now if I did it correctly, I'll get the same number because that's true. 39 does equal 39, so we're okay. Now on number 2, I have 5y minus 2 equals 3y plus 2. Again, to solve, we want to get all of our variables onto one side and all of our constants onto the other. So let's start at looking at the y's. I have 5y on the left side and 3y's on the right side. So if I subtract 5y, that'll give me a negative over here. But if I subtract 3y, that'll give me a positive over here. So that's what I want to start with. I'm going to subtract 3y from each side. That's a 3. And that's going to give me 5y minus 3y is 2y. Bring down my minus 2 equals, these will cancel out, positive 2. Now I can get all of my constants onto the other. So I want to get the y by itself, so I'm going to add 2 to each side. And I'll be left with 2y equals 4. Okay? To get the y by itself, finally I need to divide each side by 2, and I'm left with y equals 2. And again, to check that, we just need to substitute it in on each side to see if we get the same number. So if I substituted it in on my left side, that's not what I want to do. If I substitute it in on my left side, I'm going to have 5 times 2 minus 2, which will give me a value of 8. Now let's see if I get that same thing when I substitute 2 in on my right side. 3 times 2 plus 2. And I get the same number, so we're okay. On number 3, we have 8q plus 12 equals 12 plus 8q. So I have q's on each side, and when I look, I want to get them all to the same side, so it's going to be the same thing on either one, so I'm just going to subtract 8q from each side. And when I do that, 8q is going to cancel out on the left side and leave me with 12. And 8q is also going to cancel out on the right side and leave me with 12. So here's the situation. When you lose all of your variables and you're only left with constants, you have 2 options. You cannot have an answer as like a single answer. So y equals something, q equals something, a equals something, because you have no variables left. So your 2 options are either no solutions or infinite solutions. Now, to figure out which one it is, you just have to look at what you're left with. So 12 equals 12. Is that a true statement? Does 12 really equal 12? It absolutely does. since this is a true statement, that means we have infinite solutions. And yes, you do need to spell it out, I-N-F-I-N-I-T-E, solutions. That means I can choose any number that I wanted to, and I could substitute it into this equation, and I would get the same answer. It would work. So let's say, for example, I chose the number 0. If I substituted 0 in, I'd get 8 times 0 plus 12, which would give me a result of 12. And I would substitute it in over here, 12 plus 8 times 0. And that would also give me a result of 12. Now if I chose another number, say negative 12, I could say 8 times negative 12 plus 12 gives me an answer of negative 84, and 12 plus 8 times negative 12 gives me negative 84. So any number that I wanted, I could put in there and it would work. So infinite solutions, when you run out of variables and they are set equal to each other, infinite solutions is the result. On number 4, I want to get all of my variables onto one side and all of my constants onto the other. So I have a negative 6y here and a negative 6y here, so I'm going to add, I want to get this one away, so I'm going to add 6y to each side. And when I do that, on the left side, it'll cancel out and leave me with negative 3. On the right side, bring down that 3, and this will cancel out. Now on this one, if you'll notice, again, I don't have any variables. So that means I have two options, no solutions or infinite solutions. And the answer depends on my statement that I have left. So on number 3, I was left with 12 equals 12, which was true. But on number 4, I'm left with negative 3 equals 3. Now negative 3 does not equal 3. That means we have no solutions. And again, you do need to write it out. Please do not write the circle with the slash through it. I want to see no solution. That means I could choose any number to go into this problem and it wouldn't work. So for example, what if I try the number 2? So I'm going to have negative 6 times 2. Well, I'll try that again. Negative 6 times 2 minus 3 would give me negative 15 on the left side. On the right side, 3 minus 6 times negative 2, positive 2, gives me a result of negative 9. They don't equal. So when you run out of variables, your variables completely disappear, and they do not equal. What you're left with is not true. It's no solution. Let's try number 5. I have 1.2x plus 4.3 equals 2.1 minus x. Now this is decimals, but it's not a big deal. It's the same thing. I still want to get all of my variables onto one side, all of my constants onto the other. So on my left side here, I have 1.2x, and on my right side, I have negative x. For me, I feel like it's going to be easier to add x to each side. Now, if you chose to subtract 1.2x from each side, that's fine. You'll still get the same answer. So if I take 1.2x and add it to 1x, that's going to give me 2.2x. If you need to use your calculator for that, that's completely okay. Plus 4.3 equals 2.1, because these will cancel out. Next, I want to get this constant over to this side, so I'm going to subtract 4.3 from each side. On the left side, it'll cancel out and leave me with 2.2x equals, on the right side, 2.1 minus 4.3. I'm not that good at decimals in my head, so I'm going to do that in my calculator. 2.1 minus 4.3 is going to give me negative 2.2. So negative 2.2. And to get 2.2 away from this x, I need to divide each side by 2.2. So that's going to leave me with x on the left side. And if you'll notice, these two answers are the same. These two numbers are the same, except one is negative. So 2.2 over 2.2 is 1, but bring down that negative side. X equals negative 1. On number 6, I have 4.4 times m plus 11.4 equals 8.8m minus 1.8. So I'm going to start with the variables. I have 4.4 on the left side and 8.8 on the right side. So I could either subtract 4.4 or subtract 8.8. Again, it does not matter. If you prefer to have your variables always on the left, that's fine. But for me, I want to move this over here so this is positive. So I'm going to subtract 4.4m from each side. And on the left side, it's going to cancel out and leave me with 11.4. On the right side, 8.8 minus 4.4. If you need to, you can do that in your calculator. It should give you 4.4 back as a result. Minus 1.8. Now I want to move my constants all the way to the other side. So I want to get rid of this minus 1.8, so I'm going to add 1.8 to each side. And I'm going to take 11.4 plus 1.8, and that's going to give me 13.2, and that's going to equal 4.4m. Then we can divide each side by 4.4. So in my calculator, 13.2 divided by 4.4, and I'm going to get an answer of 3. All right, now what I'd like you to do is pause the video and do number 7, 8, and 9 on your own. All right, hopefully on number 7, you ended up with the result of b equals 3. Now, it doesn't matter if you chose to move the 4b over or if you chose to do the constants first. Your answer should always remain the same. On number 8, we ended up with an answer of 1/5. Now, I don't want decimals. I want you to leave it as a fraction. 2 over 10 simplifies to 1 over 5. And on number 9, we get a result of y equals 3. Next, I want to try a couple fractions. Now, just like we learned in the last lesson, whenever you're handed fractions, the first thing I want you to do is eliminate those fractions. So in my entire equation, I have 2 fractions. Now, the denominator of the first fraction is 3, and the denominator of the second fraction is 2, which means we have a common denominator of 6. So I'm going to multiply the entire equation by 6. So 6 times 2/3 in, I'm going to start with this denominator. 3 goes into 6 2 times. 2 times 2 is 4. So I have 4n plus 6 times 8 is 48 equals 6 times 1/2 n. Half of 6 is 3. So 3n plus 6 times 2 is 12. Now this equation is a lot easier to solve. So I want to start by getting all of my variables onto one side and all of my constants onto the other. I would like to subtract 3n from each side because I want a positive result. 4n minus 3n is 1n, plus, bring down my 48, equals, these cancel out and leave me with 12. Next, I want to get my 48 over here to this side, so I'm going to subtract 48 from each side. And again, that might be a little tough to do in your head, so you can take 12 minus 48, and we get a result of negative 36. So n equals negative 36, and box your answer. Now, I have not been checking these in my calculator because I'm trusting that you are doing that on your own. Checking in your calculator will only help yourself. So on number 11, I have 2/5 y minus 8 equals 9 minus 3/5 y. In this whole equation, I have 2 fractions, but if you'll notice, they have the same denominator. So that means I only have to multiply my equation by 5. So as I'm distributing this 5 times 2/5 y, 5 goes into 5 one time. 1 times 2 is 2, so I'm left with 2y, minus 5 times 8 is 40, equals 5 times 9, which is 45, minus 5 times 3/5 y. So 5 goes into 5 one time, times 3 is 3y. Now I have 2 options here. I can subtract 2y from each side, or I can add 3y to each side. I'm a little better at addition, so I'd like to add 3y to each side. 2y plus 3y is 5y. Bring down my minus 40 equals 45, and these cancel out. Next, I need to add 40 to each side to get y by itself, and I'm left with 5y equals 85. And then finally, I need to divide each side by 5, and 85 divided by 5, y equals 5 goes into 8 one time, left with a 3, 35, 17. And you can definitely do that in your calculator instead of in your head like I did. On number 12, I would like you to pause the video and try that one on your own. Now on number 12, it was a little tricky to find a common denominator between 3, 5, and 2, but it ended up being 30. And when I distributed that, I ended up with the equation 20x minus 24 equals 15x plus 60. I subtracted 15x from each side and was left with 5x minus 24 equals 60. Added 24 to each side and was left with 5x equals 84, divided each side by 5 and was left with 84 over 5. Now that is a gross answer. So when you end up with an answer like this, it's really important that you check it in the equation to make sure it really works out. So I want to substitute 84/5 back into my equation. So on the left side, I'm going to have 2/3, so parentheses 2 divided by 3, times 84/5, so parentheses 84 divided by 5, minus 4/5, so minus parentheses 4 divided by 5. And that gives me a result of 10.4. Now, let's see if I get the same thing on the right side. So I'm going to have 1/2 times 84/5 plus 2, and I still get 10.4. So even though I have a yucky answer here, it works out that that is the answer. On number 13, we're going to do the same thing, but we're still going to combine like terms first. So we have 3 times the quantity of 2x minus 4 plus 3x equals 33. This one's just like we did last class. I want to start by distributing my 3 throughout that parentheses. So 3 times 2x is 6x. 3 times negative 4 is negative 12. And then I don't multiply the 3 times 3x because the 3x is not in the parentheses. So I'm going to bring that down and set that equal to 33. Next, if you'll notice, I have like terms on the same side of the equal sign, so I need to combine them. So 6x plus 3x is 9x, and then I can bring down my minus 12 equals 33, and solve by adding 12 to each side. And I'm left with 9x equals 45. Divide each side by 9, and x equals 5. On number 14, we still need to combine like terms because on the left side, so here's my equal sign, on the left side I have a 7x and a negative 3x on the same side. So I want to add those together and I get 4x. And then I have a plus 8 and a plus 13 on the same side, which will give me a plus 21. Then I can bring down my equal sign, 2x plus 11. Now I can solve by getting all of my variables onto one side and all of my constants onto the other. So I'm going to subtract 2x from each side. And that's going to leave me with 2x plus 21 equals 11. Then I can subtract 21 from each side. And that'll leave me with 2x equals negative 10. Divide each side by 2. And x is negative 5. On number 15, again, we need to distribute first. So negative 2 times 3x is negative 6x. Negative 2 times 1 is negative 2. I can bring down my plus 3x and equals negative 32. Then on the same side of the equal sign, here's my equal sign. So on the same side, I have a negative 6x and a positive 3x. So I want to add those together and get negative 3x minus 2 equals negative 32. And then we can continue to solve like normal. So add 2 to each side. And I'm left with negative 3x equals negative 30. Divide each side by negative 3. And x equals 10. All right, what I'd like you to do next is pause the video and do the last two on your own. Okay, on number 16, I first started by distributing my 5 to get 75 minus 9g equals negative 20 plus 10g. I added 9 to each side, and then I added 20 to each side, and then I got 95 equals 19g. I divided each side by 19 and got g equals 5. Now some of you might have chosen to subtract 10g from each side and then subtract 75 from each side, which is fine. That would have just ended you up with a negative 19g equals 95, but you still should have gotten the same answer as g equals 5. On 17, I needed to distribute on both sides, so I should get 5p plus 15 plus 9 equals 3p minus 6 plus 6. Then I can combine like terms on my left side here because I see that I have a 15 and a 9 on the same side, and so that condenses down to 5p plus 24. And on the right side I have a negative 6 and a positive 6, which cancel out and leaves me with 3p. Then I chose to subtract 5p from each side because if I would have subtracted 3p, that would have left nothing over on this side, which is a little bit too much work for me. So I subtracted 5p and got 24 equals negative 2p. Divided each side by negative 2, and p equals negative 12. If you have any questions, make sure you come ask.